So on this first equation here, this exponential equation, to solve it traditionally, you make the bases the same, 3 to some power, 4 to some power, 5 to some power, but the bases need to be the same, and then you can set the exponents equal to each other. I can't make the bases the same. 3 and 10, I can't write 10 as 3 to some exponent. So to solve this, you convert it into a log. So you take log to both sides. So you're going to get log to the 3x equals log 10. Then, once it's a log, that rule that we learned in the lesson, the exponent inside of a logarithm, you can move to the front. Now, I can just solve it. So this is x times log 3. So divide both sides by log 3. And so x equals log 10 over log 3. And you can leave it like that. So on this next one, same idea. You need to take log to both sides or convert it into a logarithmic equation. So you're going to get log 3 to the x plus 1, remember that's together, equals log 5. You can move that to the front due to the power rule with logarithms. So that's x plus 1 times log 3, and that equals log 5. Now there's a few ways to solve this. You can distribute the x if you want, right? Like I can distribute this log 3 to both of those, or I can divide both sides by log 3. It doesn't matter. Whichever one you find easier. 1 times log 3 is log 3, and that equals log 5. So I have to get x by itself, so subtract log 3. And then divide both sides by log 3. That's your answer. Same thing with number 3. It's an exponential equation. I can't convert the bases and make them the same. I can't write 5 as 4 to some power, or 4 as 5 to some power, or 2 to some power, or 3 to some power. I can't do that. So convert it into a log. So then rewriting that. So now I can move the exponent to the front. Now, this one I'll just show it. You can divide both sides by log 5. And then subtract 2. Now, if the question asks you to find a decimal approximation, you would just enter those into your calculator. So here it says find the missing side of the right triangle. If you remember your special triangles from integrated 2, remember you have the 45, 45, 90 and the 30, 60, 90. So if you don't remember, you can skip this. We will be going over this again, and then we need to know it from there. So we will be going over this again. You can skip it if you don't remember, but it's good practice if you do remember. So to talk about it, those triangles, the 45, 45, 90, these ratios of t, t, t root 2, so you just compare it to the ratio. So that's t, that's t, that's t root 2. It has to be that ratio. Once you find what t is, which in this case, t is 5 root 6 over 2, you plug it in to those other sides. So I know that b equals t, so that's going to be 5 root 6 over 2. And then a is 5 root 6 over 2 times root 2, which is going to be 5 root 12 over 2, which you can break apart that root 12 into 5 times 2 root 3, because root 4 and root 4 turns into 2, all over 2. The 2's cancel out, so that becomes 5 root 3. So that's what A equals. With the exponents, remember the rules when it comes to exponents. If you have the same exponent on top and on the bottom, the degrees cancel out. Whatever's in, if you are, multiplying, you're going to add the exponents together. So in this instance, I can look at this as, now because if you have a negative exponent, it moves to the denominator. So that'll be 1 over 3 times x to the third. Well, the 3 on the top and the 3 on the bottom cancel out. You have a negative x squared times x to the third, give you negative x to the fifth. For number 8, you can consider this base being x plus 2. You don't need to multiply it out. But I have 3 of them times another 5 of them, and then I have negative 4 of them on the bottom. I can move those 4 that are on the bottom to the top. And so this becomes x plus 2 to the third times x plus 2 to the fifth times x plus 2 to the fourth. Well, now I can just combine them all together, and that becomes x plus 2, 8 to the 12th. It says graph the quadratic function, find the zeros, etc. So the horizontal shift is -2, the vertical shift is -5. So that right there is your vertex. Now to find the zeros, you have to set your equation equal to 0. And solve it. So 0 equals x plus 2 squared minus 5. You're going to want to add the 5, square root both sides, subtract the 2, so you get 5 minus 2 and -5 minus 2. It's root. Silly pen. So these right here are your zeros, and you can write them as your x-intercept. Remember your x-coordinate and then your y-coordinate, so you can write them as that. Your y-intercept, you plug in 0 for x and you simplify it, which should be here at -1. And then the domain and range, domain negative infinity to positive infinity, range, it starts at -5 and goes up forever. So finding the measure of each side here, this is where we use SOHCAHTOA again. This is something that we should know from integrated 2. So like number 12, based on this angle, I have my opposite and my hypotenuse. So I know it's going to be my sine ratio. So I'm going to say the sine of my angle equals opposite over hypotenuse. And now you want to get x by itself. So you multiply both sides by x. So you get x sine 52 equals 10. Divide both sides, so you get x equals 10 over sine 52. And then you'd enter that in your calculator, and you're going to get your answer. Last, solving this rational equation. Whatever's in the denominator, remember you can get rid of it by multiplying. So I can multiply everything by x. So that cancels out, so I get 6 plus 7 over 2 equals 5x. I still have a 2 in the denominator, so multiply that by 2, multiply that by 2, and then, so you get plus 7, equals, and then multiply that by 2, so you get 10x. So that's 19 equals 10x. Divide both sides by 10. You get 19 over 10 equals x. You plug it back in to make sure you don't have any extraneous solutions.